Again, internally, all JSX gets translated with React's create element method. So all of those JSX that is written are ultimately translated by React's create element, which is a function, kind of like an interpreter being applied to an AST to produce a runtime value. While the return one element, while we return one element as object, it has multiple inner elements as the children in this example. This becomes more obvious when calling the method for creating the elements ourselves. So if we use the actual React.create element and then use its raw parameter, you would see how the imperative, kind of like an imperative way, because you're actually defining the details instead of defining it declaratively like JSX. So like this, we're actually input the actual parameter that we are actually that automatically converted to us by React. So React done the hard work. Working with multiple components does not change this aggregation of HTML elements. Take the following code snippet where we extracted the paragraph HTML element as standalone React component. So let me just go back here because there's something idea that you need to understand when returning a single root element or a component returning a single root element. So behind this React, there is an interpreter and compiler that tracks the environment, whether you are in a inner scope or like an inner function and then an outer function which is in a global variable. For example, here cons up. So here all of this being returned here is an inner scope. So the storage mechanism under hood are tracking that, including the parent of the most tree or the grandfather basically are being tracked because the storage under hood actually track or provide a unique ID, kind of a unique ID to track that so that they can evaluate it properly depending on their scopes. So working with multiple components does not change this aggregation of HTML elements. So take the following code snippet where we extracted the paragraph HTML element as standalone React component. So we extracted the HTML as a standalone function component, such as this. Even if you traverse through the underlying HTML elements yourselves, you will notice that it didn't change from before. Only in React land we have extracted it as reusable component. So calling React's create element method would look the same as before. So here, what we did is we extract it, the text. So you may think that this text is now different from this app because we actually created a variable for that, so they must have a different scope. But since we use the text inside, or we call it React or the runtime track a unique ID, so it will say that this text actually came here from this variable. Therefore, this text just inherits from this app scope. So it actually track who is the parent and the children. As a little extra learning here, we can also mix both worlds by using the extracted component in React's create element method call as first argument. So here, as you can see, we we still use the React create element. And now we're blending what actually a raw React.create element, or kind of like imperative programming, with an actual JSX, which is a declarative programming, as because we use a text here as a parameter, as you can see, and that are will just turn into a raw JavaScript objects. So to make the example complete though, we would have to replace the child components JSX with React create element 2. So this is the child component, React.create element. So we use a React.create element for that child component as well. So return P, right? Instead of return P, we return React.create element. So when you're returning a paragraph in React using an arrow function, you're not returning a paragraph or HTML paragraph. You're returning React.create element function that turns that what you wrote as a parameter, that turns that into a JavaScript objects under hood that tracks those surrounding scope and must follow the JavaScript rules in ultimately. Now this way, we're only working with the React create element method and not JSX anymore, while still being able to extract components from each other. This is absolutely not recommended though, and just illustrate how React creates elements under the hood from its JSX. So though we can see the details, it's not recommended way to write React code, because it's a lot of overhead, and it's harder to understand for developers. Yeah, that's why you need to still use the declarative thing, and also it's prone to error, but having a deep understanding on how it works under hood definitely makes you better software engineer. So what we have learned in this section is that not only text or greeting are React elements, but also all other elements in JSX, which get translated in React create element call. So all other HTML elements in JSX are actually turned or translated by React create element call. So that's the principle of React. Essentially, you're just using the React create element function of JavaScript to turn those HTML elements into an actual JavaScript object that will turn into an actual DOM in the browser, which used to be an HTML before. So call a React function component, event target, and event listener method. So event target and event listener method. So what is this? The add event listener method on the event target interface sets up a function that will be called whenever the specified event is delivered to the target. So this basically add event listener helps you add a function that will be triggered in case that there will be event delivered to your specified target. And this add event listener that will allow you to add function is a method of the event target class or interface. So those are the class that responsible for setting up or providing a function for you. Common targets are elements or its children, document and window, but the target may be any object that support events such as IDB request. So a common target for this add event listener is element in your DOM, the document, the window. But essentially any event in JavaScript could uh, be registered on an add or function that will be triggered in case this uh, click or movement around those target that you want to notice too, such as the click of a mouse on a specific space on screen. So essentially, this is how you create the interaction from your code into an actual display in the browser. So the add event listener method is the recommended way to register an event listener. The benefits are as follows. It allows adding more than one handler for an event. This is particularly useful for libraries, JavaScript modules, or any other kind of code that needs to work well with other libraries or extensions. So, aside from allowing you to handle more than one event using that one function, which is actually how you minimize the memory as well using the flyweight pattern we discussed in the JavaScript, is that you can work with multiple libraries, because that other kind of code that needs to work well with an event could also use this function. So it is cross-platform. So in contrast to using onXYZ property, it gives you finer grained control of the phase when the listener is activated, capturing versus bubbling. So you have better control when it is activated, the time it would activate the function, when it would expire. It works on any event target, not just HTML or SVG elements. So it doesn't just work on the HTML or in the browser screen, but also on SVG or on the picture format, which is the SVG. So the method add event listener works by adding a function or an object that implements a handle event function to the list of event listeners for the specified event type on the event target on which it's called. If the function or object is already in the list of event listeners for this target, the function or object is not added a second time. If a particular anonymous function is in the list of event listeners registered for a certain target, and then later in the code, an identical anonymous function is given in an event listener call, the second function will also be added to the list of event listeners for that target. Indeed, anonymous functions are not identical, even if defined using the same unchanging source code called repeatedly, even if in a loop. Repeatedly defining the same unnamed function in such cases can be problematic. See memory issues below. So if an event listener is added to an event target from inside another listener that is during the processing of event, that event will not trigger the new listener. However, the new listener may be triggered during a later stage of event flow, such as during the bubbling phase. So the second function, for example, you have one anonymous function, and the second function has an identical function given to that add event listener. Then the second function will also be added to the list of event listeners for that target. So essentially, you're creating two functions that will listen for that event if you use an anonymous function. So indeed, anonymous functions are not identical even if defined using the same unchanging source code. So even if you define like two same code, but you define it twice in that add event listener, that code is not the same. So that's why it is registered. It will register two functions. So repeatedly defining the same unnamed function in such cases can be problematic and therefore needs to be avoided in defining in add event listener. So if an event listener is added to one event target from inside another listener, That is, during the process of the event, that event will not trigger the new listener. However, the new listener may be triggered during a later stage of event flow, such as during the bubbling phase.